You've seen the scene. The astronaut is blown out into space. In seconds, he freezes like an ice sculpture.
Hollywood loves that image. It's comforting. It makes sense. But it's a LIE.
Today you'll discover why the coldest place in the universe is where you would die of heat.
Welcome to Cosmic Truth, and this is a documentary about one of the greatest contradictions of the cosmos.
Space has a temperature close to absolute zero, 2.7 Kelvin. But you won't freeze out there. You'll roast first. And the physics behind that, will change how you see the universe. Let's start with the basics. What does it mean to say that space is cold?
The temperature of deep space, measured by the cosmic microwave background radiation, is 2.7 Kelvin. That's minus 270.4 degrees Celsius, nearly absolute zero.
This temperature was confirmed by NASA's coldest satellite and represents the remnants of the Big Bang.
Cooled over 13.8 billion years. So yes, space is cold.
But here's the problem. Temperature measures the jiggling of molecules. In the vacuum of space, there are hardly any molecules.
Less than 1 atom per cubic centimeter in regions of deep space.
On Earth, you have about 25 quintillion molecules in the same volume.
So when we say space is cold, we're measuring the temperature of practically anything.
It's like trying to measure the temperature of an empty room.
And this is where Hollywood gets everything wrong.
On Earth, your body loses heat in 3 ways.
Conduction. When you touch something cold, the object's molecules steal thermal energy from your cells through direct contact.
Convection. When cold air circulates around your body, carrying heat away. Radiation. When your body emits energy in the form of infrared without needing contact or a material medium.
These 3 forms work together to regulate your temperature. Always.
But in space, only radiation is left.
There's no air for convection. There aren't enough molecules for conduction.
You're floating in a vacuum where your body's heat has nowhere to go quickly.
And infrared radiation is the slowest method of heat transfer.
A study from the University of Illinois calculated a human body in vacuum would cool by radiation in about 4 hours, until it reached temperatures near freezing. 4 hours. You'd be dead LOong before that. But not from cold. While you cool slowly by radiation, another problem appears: the sun.
In Earth orbit, solar radiation hits 1,361 watts per square meter.
This value is called the solar constant and has been measured precisely by satellites like NASA's SOURCE.
1,361 watts per square meter.
Think of it this way. An adult has about 1.7 square meters of body surface area. That means more than 2,000 watts of solar energy bombarding your body, unfiltered.
On Earth,
Our atmosphere blocks about 70% of that radiation.
Ultraviolet is absorbed by the ozone layer. Infrared is scattered by water vapor.
But in space, zero protection.
You absorb ultraviolet, visible, and infrared radiation, UN filtered, straight into your skin.
A study published in the scientific journal Nature showed that astronauts on the International Space Station face temperatures
of 120 degrees Celsius on the sunlit side and minus 100 degrees on the shadow side, simultaneously.
Because the vacuum doesn't conduct heat from one side to the other.
Each region of your body responds independently to the radiation it receives. You become an oven and a freezer at the same time.
But there's more. Your body generates heat metabolically. Always.
Just to maintain vital functions, breathing, circulation, brain activity, you produce about 100 watts of thermal energy at rest.
during intense physical activity.
300 to 500 watts.
On Earth, that heat is easily dissipated. Cool air, sweat evaporating, conduction through surfaces. In space, that heat gets TR-apt.
A study published in the journal Scientific Reports in 2017 showed that astronauts on the International Space Station
अनुभव करें कि लंबे मिशनों के दौरान शरीर के मूल तापमान में 1 डिग्री सेल्सियस की वृद्धि होती है.
Just 1 degree. But that's enough to compromise cognitive and physical performance.
The human body operates in a narrow range, 36 to 37 degrees Celsius.
Above 38 degrees, you're already in hyperthermia. 40 degrees, brain damage.
And in the vacuum of space, with no air to dissipate heat, no cold surfaces to touch.
CO uke in your own metabolic heat.
While floating in an environment of minus 270 degrees.
So how do astronauts survive? The answer isn't heating, it's CO-ooling.
Every astronaut wears under the spacesuit something called the LCVG, Liquid Cooling and Ventilation Garment.
A liquid cooling suit. This garment contains approximately 90 meters of thin tubing woven into spandex. Chilled water, around 12 to 15 degrees Celsius, circulates through these tubes in direct contact with the skin.
The water absorbs heat from the body and returns to the primary life support system, where it is cooled in a heat exchanger before recirculating.
But here's the insane deeple. This system wasn't created to warm astronauts in the cold of space. It was created to COOL them.
Because the REAL thermal challenge in space isn't freezing, it's overheating.
The International Space Station has gigantic radiators, panels about 3.1 meters by 13.
These radiators use liquid ammonia as the working fluid.
The ammonia circulates through internal systems, absorbs heat generated by equipment and crew, and then radiates that heat into space.
But even with those massive radiators, the ISS has to do constant thermal gymnastics. When it's in Earth's shadow, for about 45 minutes each orbit, the station cools down.
Electric heaters turn on.
When it's exposed to the sun, for the other 45 minutes, the radiators work at their limit to dump accumulated heat. 16 times a day.
Because the vacuum doesn't conduct heat away. It traps heat inside until you can actively radiate it.
If you're enjoying this dive into the hard truths of the cosmos, leave a like, and subscribe so you don't miss the next documentaries.
So why does Hollywood insist on instant freezing?
Because it makes intuitive sense. Minus 270 degrees? Of course you freeze.
But intuition isn't physics. Think of a thermos. Why does it keep liquids hot for hours?
Vacuum between the walls. Vacuum is a perfect thermal insulator.
With no molecules to conduct heat, the energy stays trapped.
That's why the coffee inside the thermos stays hot, even when the outside environment is cold.
Space works the same way. You are the hot coffee. The vacuum is the insulation.
In fact, there have been real cases of exposure to vacuum.
In 1966, the NASA aerospace engineer named Jim LeBlanc had an accident during spacesuit tests.
The hose supplying pressurized air to his suit disconnected. He was exposed to near total vacuum for about 14 seconds before losing consciousness.
He survived, and he described the sensation. I could feel the saliva on my tongue starting to boil, and then I passed out.
14 seconds. No protection. And he didn't freeze.
He experienced ebullition, formation of gas bubbles in bodily fluids due to low pressure.
Hypoxia, lack of oxygen, but not hypothermia. Because freezing takes TIME.
And you would die from other causes long before that.
So here's the truth nobody tells you. Space is the most inefficient freezer in the universe.
A place where the ambient temperature is near absolute zero, but where you would die overheated.
Dehydrated. Burned by unfiltered ultraviolet radiation.
The cold? That would take hours to kill you.
Because the vacuum doesn't steal your heat, it TR-apps it.
And while you retain every watt of metabolic heat, the sun adds another 2,000 watts of direct radiation.
No atmosphere to block it. No air to dissipate it. No cold surface to touch.
Astronauts spend billions on cooling systems, not heating. Giant radiators, chilled water tubes, cryogenic fluids circulating. All to solve the same problem. How to get rid of heat? In the coldest place in the cosmos.
It's the most counterintuitive contradiction in space physics.
And Hollywood will never show you this, because it isn't visually dramatic.
But it's REAL.
The knot in your swelling part of the octet is used within the coordinates right here. You get 40 knots long.
The universe doesn't care about your intuition. It runs on the laws of thermodynamics, not movie scripts.
And maybe that's the most important lesson space can teach us. Distrust the obvious. Question common sense.
Reality is almost always stranger and more fascinating than fiction.
In the next documentary, we'll explore another space myth Hollywood loves: the sound of explosions in a vacuum.
Until then, look up at the night sky and remember, up there, in absolute silence,